Hello, hello, and welcome back. All right, if you're not doing your lab right now with me, then you're going to be doing this right here, which is understanding the difference between a land breeze and a sea breeze. So, we're talking about winds when we talk about surface currents. We talk about global winds when we talk about winds going over the entire earth, creating those surface current, ocean currents. But I want to talk about something just locally, just right outside, right where you're at. What does a local wind look like? Why do we have wind where we live? What's going on with that thing? Well, the first thing I want to show you is this. And that is if I had a sunshine shining and there's land and there's water. We did a thing where we did a test. And so with this test, what we did is we took something called a lab quest. And a lab quest is basically a device like this, and it's got a screen on it. And there's two probes. There's one probe here, and there's one probe here. And this one here is going to take the temperature of water. And this one's going to take the temperature of land. Temperature of land. Now, we're going to take this thing and we're going to run this thing for a while. So we're going to start taking data and let it run all day. And we're going to see a big thing here in this lab. We're going to see how does the temperature change in sand and water during the day. So how does temperature change on land versus water? That's kind of what we're going to look at. How does the temperature change on land versus water? How does this work? All day long, sunshine shines down on the land and shines down on the water like this. Well, when we run this thing, here's what we get right here. Our data looks like this. I'm going to go in as close as I can. Here we go. Time is down here. Temperature is over here. And over time, our blue is water and our red is land. And so if we look at this thing, it's pretty crazy how this works. As the sun starts to shine, we're going to say that this is time in minutes. So we did the kind of an accelerated thing. But as the sun shines, by the way, when we did this thing, we basically had this set up. We had two cups, one with water and one with soil. So we had soil and we had H2O water. And then we had the probes like this going in. What we found is with a lamp on, while this was shining down, we went lamp on for 10 minutes. And then we did lamp off for 10 minutes just to see the difference. Well, right down this line here, that's at 10 minutes. So over here we were on, and over here we were off. The lamp was off. Lamp is on, lamp is off. And what happened is when the lamp was on, you can see right here that the land heated up much faster than did the land heated up much faster than did the water. So land heats faster than water. Fact right here. You could say that's a fact. Land heats faster than water. And another fact that we learned is that land cools faster than water. Interestingly enough, water stays pretty much the same. Check this out. Your water pretty much stays the same. So water is not going to change a whole ton. Your water data goes up and goes down, whereas your land data went up and down like this. Why is that? Why does that happen? Well, the reason why is when we're talking about water, we're talking about a fluid. So if you're sitting in a cup, you have a fluid, water. This is water, by the way. You have a fluid. So these H2O molecules can move around. This could go down. This could come up. This could go down. This could go up. This could rise up. It's moving. It's fluid, which means it moves. So it takes a long time to heat up. It takes a long time to heat up. In the same sense, water also holds heat. Water also holds heat. So not only does it take a long time for it to heat up, but it also takes a long time to cool down. Okay, so that's for water. That's for water. If I look over at land being different, land, if we had a cup of just dirt sitting here, it's a solid, so it doesn't move, believe it or not. And the top portion, the top just keeps getting heated. That's basically what happens. It's not moving around. So you're just going to see this thing heat up really fast. So land then heats up fast and cools down fast. Land heats up fast and cools down fast. Those are the two things that we learned. Opposing water, which water takes a long time to heat up and to cool down. And you've probably ran through this experiment and not even thought about it. But when you go to the beach, when you're at the beach and you show up and you're walking out on the sand, this is your sand, and it's 8 o'clock in the morning, the sand on your foot, the sand feels cold at 8 a.m. You're not too worried about it. Sounds good. Everything's great. Now, if we go further, though, the sand at the same place, but let's say it's 2 p.m., your foot is going to hit the sand, and before you know it, ouch, your foot is going to burn. Your foot burns at 2 p.m. in the summertime because that sand is stinking hot. And you're like, what the heck? I came out here this morning. It was cold. Now it's stinking hot. What is going on? But the water would feel the same. Yeah, you're right. In the morning, the water feels the same as it does in the afternoon. It doesn't change much. But the sand, man, it gets hot during the day. That blacktop pavement gets hot during the day. It gets cold at night. But the water doesn't really change. Interestingly enough, it's because land heats faster and cools faster. Same thing with water, going slower when it heats and slower when it cools. And so here's our data once again, and we can see this effect take place. How does land and water heat and cool? Once again, land heats much faster. And then when you turn off, so right here, I turn off the heat, land cools much faster than water does. Water actually will hold in some heat for a while, interestingly enough. So that shows us the data right there that kind of explains to us what it is. And so going back to our starting question here was this. How does temperature change on land versus water? And so we did this experiment, and what we found is that water warms and cools slower than land does.